Okay, I'd like to welcome you to the Maps API and mobile talk today. I'm Susannah Raub. I work at Google on the Maps API team in Sydney. And we would like you to not forget to provide feedback on my presentation by going to this website, haveasec.com/io. We will incorporate your feedback for next year. All right, welcome. So, Google Maps API. What are the options on mobile devices? For lowest common denominator phones, we offer the static Maps API. This requires no JavaScript and works on both phones without JavaScript-enabled browsers, and also when you're trying to load just a simple map very quickly and don't need the full interactivity of the full JavaScript API. We also have a number of native APIs, or one for Android, one for iPhone, called MapView and MapKit. These are developed in Java and Objective-C for the iPhone. These give you a real native experience the way that the native app does on these phones. But then we have the JavaScript API. And the JavaScript API will work on iPhone, fully supported, Android to some extent, and then in the future, Nokia and Palm. We haven't tested these browsers yet with our APIs, but we believe they should work because these are using fully featured browsers, high-end devices. So let's talk a little bit more about why we might develop in the browser. So as Vic said at the keynote yesterday, developing in a browser allows us to write one application that works on many different platforms. You'll let us solve the cross-device issues instead of worrying about writing your application once for the iPhone, once for Android, once for Nokia, once for Palm's new device announced yesterday, and who knows what's coming tomorrow and where you're going to have to write your application one more time. This way, your mashup is also available not just across different mobile devices, but on the desktop as well. And this goes both ways. If you write a mobile app, a desktop user can still access your content, and if you've written a desktop app, as long as it looks okay on the mobile, a mobile user can use it too. Of course, download is a great barrier to entry. So by writing an application in the browser, you require no download, same usage model that people are used to for accessing things like Gmail and other great applications in the browser. Also, we can release features and bug fixes much faster in the browser than a downloaded application can. You've got to worry about supporting your old client applications that are already on phones and the difficulty in upgrading everybody to your new system. That goes for both your application being able to iterate faster, but also the API, that there will be bugs in whatever API you're using at some point, and we can get those fixed for you right away, whereas the application will rely on you re-downloading it, or the client API. But this comes with a few problems. So what makes developing in a mobile browser tricky? Some of these apply to mobile in general, but we've got this issue here that we would like to develop applications that work both on mobile browsers and on desktop. So we've got issues around screen size. We need to think about what do you do in this limited amount of space? And I forgot to introduce, but I'll comment now. We've got Ken from Lonely Planet back here. He's going to talk later. And he's working on an application for Lonely Planet that does just this, is take into consideration what can you present to a user in this small space on this different model than we're used to on the desktop. So we have issues around screen size. We also have issues around how the user interacts with the map. That we have great new technology with being able to touch and to pinch and things like this, but it also means we need to figure out how to best write our applications so that we take advantage of these great features. Then the big one is speed. Mobile devices are slower. They are slower from the CPU side of things. They're also on slower networks often with the 3G or even not 2G networks. So we need to deal with issues of reduced bandwidth, but also reduced performance speed actually running on the device. And then the last one is the one that you guys have to tackle, and this is the use cases. How can we write applications that make use of the mobile usage, that make use of the fact that people are out around town, not sitting at their computers at home. So that's where you have to come up with great new ideas. So let's talk about speed, because this is really, I would say, the biggest thing with the biggest difficulty in developing on a mobile device, and particularly in the mobile browser. We have issues in the mobile browser that don't affect the native app. One of these is that as iPhone Safari is approximately 10 times slower to parse JavaScript than desktop browsers. This is a huge hit. And this isn't even talking about wireless versus a 2G or 3G network. This is not the time to download. This is purely what happens when the JavaScript arrives on your computer or on your mobile device. Also, caching is limited compared to desktop browsers, where you can depend on your large JavaScript files, your images, being cached in a desktop browser, so it's a one-time upfront hit for the developer or for the user. On a mobile device, the cache is small. It'll only hold small items. As you change windows on the iPhone, each time you go back to a window, it refreshes the whole page. It has to re-download everything. The cache is not preserved across pages. This certainly for our Maps API was a big deal. And then every millisecond matters. I think we've said this in a few talks before. We mentioned this yesterday in the performance tips for Geo APIs. I believe Vic said it in the keynote yesterday. We've found at Google that every millisecond that it takes to load a page is fewer users. Users will give up, particularly on these mobile devices where who's seen their iPhone just sit and spin and spin and spin, and eventually you have to give up because you have no confidence it's ever going to load. So let's talk about what causes these speed problems and these causes of latency. One is serving data. At Google, our servers are pretty fast. We're pretty confident in their ability to serve our data quickly. The time that we're seeing here is negligible compared to the time it takes, these other issues, the downloading time, the JavaScript parsing time, the performance actually on the device. Now that said, living and working in Australia, I want to say that if you believe your users are spread out around the world, do look into caching solutions in other places to get your data closer to users. Distance matters. It takes a long time to cross the Pacific. It's my little plug for Improve Your Apps for Australia. Then download time. So here we need to look at both bandwidth and latency. Mobile devices have access to wireless networks, and 3G is actually fairly high bandwidth, but they're also high latency. This means that loading small and big files take a surprisingly similar amount of time. You don't gain a lot by downloading small files. In fact, you're going to be hurt by downloading lots and lots of small files as opposed to perhaps one medium or big file. Then there's the JavaScript parsing time. And as I've already mentioned, we've seen it to be about 10 times slower on the iPhone than on a desktop browser. This is CPU bound, and we expect it to improve over time, which is the good news, that as the hardware improves, we're seeing improvements. Also, as the software improves, the JavaScript parsing libraries are getting better as well. So this may not be a problem forever, but it's certainly a problem now. I want to back up a moment, and I'm using this term latency, but what is it? And I want you to think about it in two ways. One is that it's the page load time. It's the time it takes until absolutely everything on your page is visible, loaded, visible, and usable. But then, maybe more importantly, arguably, maybe not, is user-perceived latency. And this is the time until the page appears to have loaded. So this is the time when a user says, OK, my page is here, and I can start doing something with it. And even if things are still loading in the background on non-visible parts of the page or things they're not going to have to interact with right away, this really improves the user experience. This is we measure both of these. And this is another point I want to make. Measure these things. Measure how long your page is taking to load and how long. Define what it is until the user is able to use your page, and measure that as well, and work to reduce both of them. So how can we reduce latency on mobiles? One, we can reduce the size of JavaScript. I recommend compiling or obfuscating your code. Compiling it can help you catch errors, but more importantly, by obfuscating it, you can take all of your long variable names that make your code nice and readable, It takes your variable names, your function names, your class names, and makes them into short 1, 2, 3 character variables, functions, and class names. You may have noticed that the Google Maps API is obfuscated. This may make it a pain sometimes to debug, but it's not just there so that you can't read our source code. It is also there so that we can load this API as quickly as possible for you. You can reduce the size probably, I guess it's about 10 times, 100 times. It's remarkably slower. And there are compilers out there, obfuscators, that do lots of optimizations around strings and other, all kinds of optimizations to help reduce this even further. It's not just simple renaming. The other thing is to combine your image fetches using sprites. You may have heard this one before. Each download on the iPhone has significant overhead. And there are a limited number of open connections on the iPhone, like any browser. And so by combining your images that are all going to be used at the same time into one, and then spriting them, putting them in separate divs, will help you out a lot. So what happens when you either don't have JavaScript available on the phone, or you really need something super, super fast? We have the static maps API for you. We have some people who are using this where it loads a static map and then converts it to a dynamic map after the rest of the page is loaded. This is a great way to reduce user-perceived latency. Or sometimes on a page, you may want a map showing, but you don't need to load that whole map unless you really think the user is going to interact with it. And so you can delay load the actual JavaScript at that point as well. So we see that there are a number of parameters that you pass it fairly simply. There's a center, a zoom, a size. The map types available are terrain, road map, satellite, and hybrid. And then you can even put markers on and polylines. It requires an API key. And then you need to specify whether or not you're using this on a GPS-enabled application by specifying the sensor parameter. That's all there is to it. But say you need to geocode with it. Well, instead of downloading the whole API in order to do your geocoding with the G-client geocoder, you can use the HTTP geocoding service. Reverse geocoding is also available, and like the static maps API, it's just passing a few parameters. So you give it the query, your output, which can be JSON, KML, CSV, and XML. And your encoding also requires an API key and the sensor parameter. So now you can build a full map with geocoding without having to download a bit of our JavaScript. But let's go back to the JavaScript API. How well does V2 work on mobile browsers? Ken, how well does it work? Not very, he says. So the initial download back when it was released in 2006 was 60 kilobytes. It's now about 190 kilobytes. That's because we brought you so many great features. The time to load tiles also really affects how our API does. That because we're loading these tiles, we give them some padding. It can take a long time to get those tiles to you. We have synchronous access to a lot of state, and this has limited our ability to delay load code. So because we give you, for every single feature we release, all these different getters after you've manipulated the map in some way, means that we have to actually, up front, synchronously, we have to have computed all of those values. This code base was not designed with mobile in mind. It is a great API, and it works very nicely on desktops, but it didn't need to fit the needs of these browsers back when it was written a few years ago. So here I'm going to introduce to you today a new version of the API. Oh, good, I like this. So we released this API yesterday, and it's right now a limited feature set of the V2 API, but we wanted to get it out to you, let you start writing your simple applications on it, and using I'll talk more about our architecture, but using our behind-the-scenes architecture to write some really rich applications on it. We wanted you to do this fast, right away, so that we can start adding the features, the more complex features later. So how does V3 address the issues that I've brought up previously? First, the initial download side is significantly reduced. It's 35 kilobytes. So we're just about half of what the first API was 3 years ago. This significantly reduces the loading time, and I'll show you this in a moment. We incorporate the static map for you by loading that first before tiles load. We even make it draggable, and this is to reduce the user-perceived latency. So you shouldn't even notice that we've loaded the static map in first. We're designing it with mobile devices in mind, so we've tried to get it to feel like those native APIs, what's available if you run it natively instead of in the browser. And we're seeing that as hardware improves, so as hardware improves also on OS 3, we're seeing that this is really starting to feel good. So let me show you V2 versus V3. I'm going to load them both. Now, the network, as you may have noticed, is sometimes a little hard to connect to. So last night, while everybody was partying, this worked beautifully. We'll hope it's still... So you can see they look the same, right? Oh, wait, I'm on the wrong thing. Now you can see they look the same. Okay, that looks good. So I'm going to go here. I'm going to click on a little... Let's make sure I get this right. So we've got here, I'm going to press go at the same time. And the one on the left is V2. The one on the right is V3. To emphasize this, the V2 one is running on our brand new, shiny iPod Touch running OS 3. And our V3 one is running on the slightly older iPhone with OS 2. All right, we're having some network connection problems on the iPhone. Okay, we'll try again. So OS 3 is the one running V2, so it says V2 over in the Southern Ocean. Okay, I'll try again, and then we'll... Well, the cache should clear itself. Okay. It worked so beautifully last night. It's too bad on OS 3 I can't get my finger to drag, ever. Okay. There we go. Yeah, that's right. It's the network. No, neither of them want to connect. All right. No, they're both on Wi-Fi. It says that AT&T, but data roaming's off. It's actually, we don't have 3G access because they're for Australia. So, okay, my race isn't working today. But you can believe me that it is faster. So here we go. Here are numbers for you. We found, in general, what's that? Oh, I need to switch. Thanks. So in general, we found that it takes about 9 seconds in V2 to download that first JavaScript download, which we call main.js. It takes about 2 seconds to download that on this is over, we believe, over 3G for both numbers, so about 2 seconds on V3. Now, V3 numbers are purely in our test lab. It's not been used by enough people to have really good numbers the way we might have for what's out there live, but this is a pretty good estimate of how long things take. And then the time to load tiles, which I'm actually defining as the time to load a map that can be dragged, is about 18 seconds on V2 and about 7 seconds on V3. And we see great improvements on that on wireless over 3G for that tile downloading. So you can see it wasn't, oh wait, this guy. You weren't watching. I was watching. this one was really still very slow because I think it's the iPhone versus it's just not connecting well. So it wasn't V2 and V3. So how did we accomplish this improvement? As I mentioned, we're using this static map under the hood to render the map faster. And this will happen whenever you change zoom levels and when you load a map. So we should be getting you the fastest map possible when there's a big map change. Now, the other improvements were made mostly because we use this MVC architecture. MVC being Model View Controller. So what we do is we load our state storing models initially. This way you have access, everything you access is a model. And you have access to set and get the properties of that model. And when you create something like a map, we then asynchronously download the code necessary to render that, which is completely separate from the actual model that's storing the state, where your zoom and your center and your map type are. So when we download the views for the map and the marker, we get all of the complicated divs and CSS and interaction and event handling. But once that's downloaded and the user can begin interacting with the map, the events that happen there affect the model. So for example, when the user double-clicks, we change both the zoom property and the center property. These properties then are changed back on the model because we've used this binding where they really share the value. The model can decide at that point whether it wants to take that value or whether it needs to edit it. For example, on zoom, the model says, wait a second, this zoom level you've given me is invalid because we've gone one level too far or one level too far in either direction. And the model says, nope, I'm not going to accept that change. It doesn't update its state, so nothing gets notified of a change. But if it does update its state, then everything that is bound to that property throughout the entire system updates that change. So I'm going to show you an example of how to use this. But before that, I'll explain you could do something where you have a div that's displaying the zoom level. And if you bind to this zoom change property, you will at any time be able to just get the zoom level from it. I'll show you more later. Because we are only loading a small state storing model for each feature that we have, we expect that our size increase for new features will be minimal. You hopefully will not notice any impact of new features on the size of the download. This has also helped us to untangle code and should help us to add new features and fix bugs faster. So what does V3 look like? It's somewhat similar to V2. It is a totally new interface, so you will have to rewrite your applications from scratch. There's absolutely no backwards compatibility, though we have tried to maintain the same features. Well, features not quite because we've started with a very small set, though plan to add features. But if a method returns some value in V2, we're trying to return that same value so that it's a port, not a full rewrite. So you can see that you create a map, which is all stored in a Google.Maps namespace, and pass it a div, just like before. And then you can pass, right now as an options object here, the center, the zoom, and the map type ID. Not a map type object, but a map type ID. You pass these in, and this will create a map right away. If you want to wait and set the center and zoom and map type ID later, and I'll show you an example why you might want to do that, we also have methods that you can call set center, set zoom, set map type ID. Then we can create a marker to go on this map, and we give it a position, and we give it a map. And this will right away render it on a map. You can hear also we have functions, methods available for you to set these properties individually. So if you wanted to move your marker at some point, you can just say marker.set_position and give it a new lat long. So let me find a demo here. I'm going to find it, then I'll show it to you. Oh, wait, this one's on here. So here's a demo using this MVC architecture on V3. So we have a big map, and you'll notice in the right-hand corner that there's this little overlay map. Now, in V2, there was an overlay map option, and this takes probably hundreds of lines of code in in that main.js file that you're downloading, hundreds of lines of code are needed in order for you to be able to display this overlay map. But I'll show you how you can implement one of these yourself using MVC and v3. Here's the code. Can you see that okay? I did my own syntax highlighting, so I hope you can see it well. So what we're going to do is we're going to initialize two maps. One is full size, and that's defined by the divs that you've created down below in the page. And one is a small div in the corner of the large map, calling these map and overlay map. So I've initialized a map, but I have not given it any properties to begin with. Then in the overlay map, I'm going to specify that it's got a roadmap type. It's not going to change. It's always going to be roadmap. And I'm going to disable the default UI. Disabling the default UI means that we won't show you the zoom control, the map type control, or any other controls that we decide to put on it someday in the future. Then I'm going to set up these two event listeners where I'm listening to the zoom changed event, because what I want is the overlay map to show the same exact map as the big one, but 4 zoom levels out. So the map, and I want the map, if you zoom in on the overlay map, I want the map to reflect that change as well. So I'm going to have the map listen to the event, or I'm going to listen to the zoom changed event on the map. And when it changes, I will calculate the new zoom level, which is 4 zoom levels higher than or zoomed out than the map, and set that to be the zoom level of the overlay map. I'm going to check that it hasn't changed to avoid some infinite recursion here. Because then I'm also going to listen to the zoom changed event on the overlay map, which will be triggered anytime the zoom level changes there, either through set zoom or the user double-clicking on the map. And when the overlay map zoom level changes, I'm going to reset the zoom level of the map. Then, because I want their centers to stay in line, I use this method called bind_to, and I bind the overlay map center to the map center. This means every time the map center changes, the overlay map is notified of a center changed, but also its center just is the same. Every time, if you called overlay map.getCenter, you would get the actual same object that map.getCenter would return. So not just the same value, but the same exact object. Then I'm going to set the properties on the map. The zoom is the important one here. I didn't set the zoom initially, because if I had set the zoom initially, then the overlay map would not have been notified yet of the zoom changed event. The zoom changed event happens as soon as set zoom is called. So now I set the zoom, and just because I was setting the zoom down here, I decided to set the center and the map type ID. Unlike these event listeners, bind_to will notify of the initial setting of this property when you call bind_to. So in the case, if I'd set the center above, then I could have said overlay map.bind_to map center, and it would have gotten a center changed event. Now this may sound fairly complicated. You don't actually need to use this to write a simple map application. We can hide most of this from you. But I wanted to show you how rich it can be, and emphasize that each of these MVC properties, zoom, center, map type ID, these are the bindable properties. These are represented with this set underscore and get underscore notation. This is because it's how it's implemented on the back end, but it makes it clear which are MVC properties and which ones are not. There's also, you'll notice on this, where was my demo? On the demo, there's this blue rectangle in the corner. I've elided the code for it, but that blue rectangle is being shown because the map has a bounds property, and it is binding to the bounds changed event, or I think it actually implements a method called bounds changed, which is another way of doing this, and we'll have more documentation on that. But it pays attention to the bounds, and it renders its blue rectangle as the bounds of the map change. And I will give you time to ask some questions. But something else that we're making sure that we do in this case in v3 is to adjust for screen size. So though v2 did some of this as well, we're really taking it seriously in v3, making sure that your info windows don't appear larger than your map, making sure that your controls are the right size, Not even on the iPhone, we won't even show you the zoom control by default because you can pinch. What else is new in V3? Chrome is supported, iPhone Safari is supported. Android works pretty well, but we've still got some bugs that we're working out. So though you can use it, we're not officially supporting it. Big news is no keys are required. You can now run your application on any domain. You don't have to register for different keys, none of this. So you're welcome. We also, the default UI is enabled by default. So this means that if we introduce new UI elements to maps.google.com, you will see them on your API site unless you disable the default UI. So you can disable the default UI and you can control all of the controls yourself, but you don't need to if you just want to follow along and get our updates as we add new things to it. Included in this is keyboard handling. When we implement scroll wheel zoom is part of the default UI. Another big thing that we do is we adjust your controls for the size of your map. So if you want a large zoom control on a big map and a small one on a small map and none on the iPhone and the Android style on the Android, we'll take care of that for you. Just leave default UI enabled. We also have a new geocoding API. So we took into consideration all the things that you've been telling us for the last few years and have a new API. The old one is not available in V3, but we think you'll like the new one better. And as I've mentioned, we have limited features now. We have a map, marker, info window, custom overlays, which can be implemented using something called the overlay view, geocoding, probably some more that I'm forgetting, but these are your features today. And I'm going to demo, hopefully, one of our trusted testers is Trapster, and they have an application that is running, that shows you live traffic based on GPS devices. And so here it is in the iPhone, and I loaded it before, so hopefully it'll still be working. But you can see you can click on any of these little markers, and it shows you the speed and the date and time of what's happening there. They've implemented their own zoom control here. And you can see that though tiles are taking a little while to load on here, that it's working pretty well. So the poor network. Okay. Well, we're not loading tiles right now. Okay. Let's, I'm going to go back to V3 and show you some of or my demo page and show you some of our panning and zooming. Hopefully it'll finish loading. If you're using your phone right now, maybe you could stop. I encourage you to try this outside of this building. You may have witnessed already that our connection is difficult on the mobile devices. Okay, well it's not loading right now, so I think I'm going to hand it over to Ken. Well, here we go. So here's
If you get it up on that, just bring it up.
So he asks about the version 3 tile server. We're using all the same tiles. We're using all the same images. Everything, all that back-end infrastructure is the same. So you can see that I zoomed in there using pinch to zoom. And once the tiles are loaded in there, it works pretty nicely. All right. So now to hear from a developer using the Maps API, I hand it over to Ken, and I'll be back up for questions.
Thanks. Great, thank you, Susannah. So I should switch. I'm Ken. I'm from Lonely Planet. If you haven't used Lonely Planet, I'll just give a brief introduction. We are a guidebook company primarily. If you go to a bookstore, you go to the travel section, you'll find all sorts of guidebooks there that we produce. Country guides like this one to Nepal, city guides, New Orleans. We have a new series called called U.S. Trips. California Trips is one of them. Guidebooks for how to travel very, very cheaply. It's some people don't realize that you can travel on $10 a day if you go to the right place. Activity guides, language guides if you need to learn Burmese to speak to a monk when you get there, and sort of pictorial coffee table type books. This last one is my favorite. It's the Lonely Planet Guide to the Middle of Nowhere. We also have a digital side of our business. We have a website, lonelyplanet.com, a mobile site for the iPhone, touch.lonelyplanet.com, which is what I'll be talking about really here. Mobile site for other devices, m.lonelyplanet.com. Native guidebook apps for the iPhone, native phrasebook apps for iPhone, Android, and BlackBerry, and then a couple new applications that are coming soon for Android. So thinking about maps on mobile devices from a traveler perspective, this is really, really rough. I've said 3 main features, and obviously we can debate this. We could have a whole session on what we really want maps to do on a mobile device. But I just said sort of 3 really basic things, like where is it, meaning there's a pizza place, or there's the Bay Bridge, or there's whatever it is that I'm interested in. I want to know where it is, what's around it that might be interesting to see while I'm there, and then to get me there, to navigate me to that place. Now, that could be simply by looking at the map and following it by looking at street signs, or perhaps there's a GPS integration or driving directions or something like that. And if we can locate the device, then you can start to ask a couple more interesting things, like where am I right now, and what's around me right now in this moment. So how do we deal with that in all of our mobile products? For our iPhone City Guide app, we have a tiles server. We actually cache tiles on the devices, and we use the Raub library. And that solves sort of all 5 requirements that I just sketched for mobile, but it's not cross-platform. Obviously, it's a native app on the iPhone. For m.lonelyplanet.com, we use the static maps API, as Susannah mentioned later. So we can display points of interest and things around them by generating a static map with markers on it. And then we've simulated map navigation by using Mercator projection class on the back end, which can decide what the URL of a static map that would seem to have been the place you would go by navigating north, south, east, or west. Does that make sense? So we have links that go up, down, left, right that will move the map, but they actually take you to a new page that has another static map that is just shifted. And that's sort of adequate for where is it, what's around it, when I see a point of interest on our little mobile site. But, the get me there part of it, the where am I, what's around me, obviously is not very well supported. And on our iPhone site, what we did is we created a KML link to the iPhone's native maps app because what we had available to us in the browser just wasn't sufficient. And it was actually a big debate internally about how we could do that. Should we use the static maps API on the iPhone site, or should we link to the native app? And we decided we should just link to the native app, even though that meant that people would be leaving our site and maybe never coming back. Well, hopefully coming back, but not coming back potentially, because when they're in the native app, they start doing searches there. They do directions lookups. They use the GPS. And the iPhone users really are expecting that kind of rich functionality on the iPhone. It's pretty hard to give a static map on a website on an iPhone and expect people to be satisfied with that. So the alternative, when Google sort of approached us and said they're building this new JavaScript Maps API that was targeted at mobile, was perfect for us in the context of our browser-based iPhone website, touch.lonelyplanet.com. So it's great for the where is it, what's around it kind of thing. If you're looking at a point of interest, in OS 3.0, the geolocation API will be supported, so we can start to get the user's location into the browser. It keeps the user on our site instead of having to go to the Maps application on the iPhone. And we can still open the native Maps app for directions, or just give the user that option should they desire. So I'll just do a demo. And this is live. So if you go to touch.lonelyplanet.com on your iPhone, And I will also not tell you that if you go there on the Android phone that you were given, it will not work, and that's because we don't support it. If that makes sense. So in I'll say it more simply. It works on Android, but we don't support it, and there are a few bugs that the Google Maps API still has. But you can go try out touch.lonelyplanet.com on your Android phone and see an implementation of the new Maps API. Oh, I should switch this. Okay, so that's the front page of touch.lonelyplanet.com. I'm going to find a destination. And it remembers one of my previous locations, so I'm not going to bother typing. I'll just pick San Francisco. Come on, network. Great. So there's all sorts of things that we have here about San Francisco. Things, weather, health and safety, that sort of thing. I'm going to go to things to see and do. Dare press it again. Should have taken dance lessons from Lars this morning. You got it up on yours? Oh. Why not? This is what you get? Mine's still not there. Okay, sites. I'm going to see what's around to see. I'm there on this phone now, so we might have to just... Fantastic. So there's all sorts of places that I can see around San Francisco. I'm going to pick, I don't know, Bob Kaufman Alley. Check that out. Does anyone else have another iPhone and manage to get ahead of me? Yeah. Oh, it's up. It's up. Okay. Well, here's the part that I was hoping to get to quickly and then spend a bit of time on is if I click Show and Map. Cross your fingers. Where previously this would link out to the iPhone's native app. Once this loads, I should mention that we're based in Australia, so that's why we don't have 3G on our phones either. We got Australian phones. You would get something like this. And as you can see, we've created our own, well, not our own, we've copied an info window from another place you may have seen before. That's a custom info window that says Crossroads there that is implemented using the overlay view class in the Maps API version 3. We've used custom icons that we had. What we've done is we've made an AJAX call to our content service to load in all of the, in this case, it's the shops in San Francisco onto the map. And then a few other features of what we've done. If you scroll the map, we're listening to the bounds changed event, and it will populate other things that are outside of the map bounds. And that helps keep it zippy on the iPhone browser, which isn't a very high-powered browser for JavaScript. So then I can just click on one of these. I can click on the info window, go to that point of interest. I can ask what's nearby that one. To get a list, I can show that list on a map. There we go. I can switch between places to shop and places to see, and you get the idea. We haven't, all of the pinch events and the swipes and all of those things are included by default in version 3. We haven't done anything differently on the interface side of things. And actually, if you go to this page and start using our site on your Android phone, you'll see that there are actually zoom buttons that will appear on your page because the API recognizes that you're on Android and not on iPhone. And if you go to touch.lonelyplanet.com on your desktop browser and load it up, obviously the experience isn't designed for that, but you'll see the default UI for the desktop browser show up. And I think that's all from me. We'll move into questions now. You can ask Susannah whatever questions you want, or ask me anything about implementing this that we ran into.
And if you come up to the mics, then maybe that will happen. If you come up to the mics, then that helps everybody hear your questions. So we encourage you to do that. All right, here we go.
Are you planning, hello, can you hear me? Yeah. Are you planning to do sort of the map view also eventually? I mean, it's nice that you guys kind of recreated that, the view. So I'm just wondering if that's something that...
Do the map view. What?
Sorry. I mean, it looks like the native iPhone sort of maps control.
Oh, that's a question for me.
Right.
That's a custom info window that we created. Okay. Which our source isn't obfuscated. You can just go look at it and check out and go use it yourself. We did that to give the feeling that people have when they're on the native app. Right. So it gives a feeling of the iPhone experience.
Okay.
Yeah.
So when you show me a bunch of restaurants, that doesn't mean much to me. I'm not interested in just going to any restaurant I happen to be nearby, right? So are you going to add more depth to what you find in terms of maybe personal preferences I might have stored in my contact information, or something that gives me a little bit more intelligent search for things that you show up on Lonely Planet?
You're asking a tough Lonely Planet product question. How about we talk about that offline? That's all I can say. That's all I can say.
Yes.
Hey. I know this discussion has been in the context of mobile, but I'm wondering if any of these any of the V3 API will be available from within the Google Maps Flash API. Or is that another
this is purely JavaScript now. The Flash API is completely separate. Are you asking if like the MVC stuff would be available in Flash, or
more just kind of the optimizations that you've made in terms of the static image loading and things like that?
I can't maybe.
I think it's something that's lagging slightly from the JavaScript, but we certainly work in the same team next to each other.
Okay.
The methods get bounced around.
We
Right.
Please watch this space.
We have found that on desktop, loading the static map first doesn't make such a big difference. Like, it definitely makes a difference, but it's not as critical as it is on the slower mobile devices.
For sure.
Yep.
Cool. Thanks.
Thanks.
So in version 2, there was a quirk mode, so you can get it to work with other device types like netfront browsers and alternative browsers. In version 3, you're focusing on mobile, right? So is it centered around WebKit? So if I'm using like netfront, which is an access browser, or Limo, which is an open source browser, is it going to render that way as well?
So it should be the same across browsers for now. We do test on WebKit browsers,
Okay.
but we haven't done anything special for WebKit browsers versus other
Nothing
browsers.
special? Okay. Cool.
Not yet. Before everybody leaves, I would like to comment too. We have a fireside chat for Geo at 12 o'clock in the fireside chat room. So if you have questions that go beyond just this API, come join us there. And you should also give feedback on this presentation at havasec.com/io. Now on with questions. Yes.
Can I have a questions on the static map? Because I use static map for the first load. It'd be nice to support polygons. I've been requesting it for your more
It
than
would be
a year
nice
now.
to support polygons. You're right.
Will it be supported?
We'll work on it. We know it would be nice.
Yeah, that's a cool trick to, instead of the users look at a white space to load that first.
Yep.
Hi. Are you going to roll the app cache stuff into the V3 API?
So that's the app cache stuff is the HTML5 database stuff? Or
Yeah.
Yeah. So we've looked into some of this stuff. I believe it's difficult to do cross-domain, and so I think it's something you can put on your site and take advantage of. But we may not be able to build in ourselves.
Okay, thanks.
Just have a question about the draggable pin. Is that possible also in the browser with this new version?
The draggable
Pin that you can do in the native Maps application on the iPhone?
that you can drag the marker.
Yeah.
Not currently, but these are some of the features that we have in V2 that we would like to have. And once we support draggable markers, they will work in the iPhone as well. But right now, they're just clickable. Any more questions? Thanks for joining us, and good luck writing your V3 applications.